In this sample system, there are 100 decoders in the path. The typical decoder will use between 0.6 and 5 milliamps. This will vary by brand, of course, so let's say that these use 1 milliamp. If we clamp the meter around one wire at the start of the path, we should get a current flow reading of 100 milliamps with no solenoids activated. Be sure to place only one wire, the outbound wire, in the clamp to get an accurate reading. If we were to activate a zone, the energized solenoid will add about 200 milliamps of additional current flow. The consumption of a valve solenoid varies by brand and is published in the manufacturer's catalog. Assuming you're taking milliamp readings with no solenoids activated, you'll see that it's easy to calculate what they should be at each step in the path. On our system with 100 decoders of 1 milliamp each, the reading at the start is 100 milliamps. The reading between the 5th and 6th decoder should be about 95 milliamps. Before the final 5 decoders, it should be 5 milliamps. If there's a change in this logical progression, you know there's an issue like a break, a bad splice, leakage to ground, or a bad decoder. For example, if your design is meant to draw 100 milliamps and you read only 30 at the controller, well, that means 70 of your decoders have been cut off from the system. If we know the total system normal milliamp draw, we can perform some simple checks before we go out into the field to help us determine what we're going to be looking for. Note that the milliamp draw for multi-station and special device decoders will be higher. Generally, decoders for single valve operation will draw 0.5 to 1 milliamp. Multi-station, pump, or sensor decoders will draw 3 to 7 milliamps. The as-built drawing can help you identify if these are used in your system. Excess current will indicate a short or open. Low main current will indicate a break or an open splice. In the next section, we'll cover these in detail. Let's examine how to find what's wrong when a specific valve or group of valves will not activate. If you have a whole group of valves that don't come on, you know the fault will exist between the last working decoder and the first one that does not work. Using our same example, at the 61st decoder down the path, our reading before the decoder should be 100 milliamps minus 60 or 40 milliamps. Taking readings in this 61st valve box, we will probably find something other than 39 milliamps after this decoder. The troubleshooter can replace the splices or change the decoder to attempt to isolate the problem. It can be a bad splice, a damaged or bad decoder, or a problem in the wire itself. The most common culprit will be a bad splice. If your problem is just a single valve, your issues could also be the valve itself, the valve splices, or the solenoid. Refer to our video on wire splicing for tips on diagnosing and replacing splices, and our video on solving electrical problems at the valve for the procedure for testing the solenoid coil. Most controllers will display an alarm, or otherwise go into short circuit mode when there is a short in the field wiring. When measured at the controller with a clamp meter on the main cable, a short circuit will display a dramatically higher than normal current flow. This can be caused by a bad decoder or unintended crossing of the two wires in the path. To resolve this, you'll need to follow the cable path, looking for areas where the cable may have been disturbed by digging. If your layout has multiple legs, you may be able to isolate the short to one of the legs if they terminate at the controller. Once you know what leg to work on, go halfway down the cable path and disconnect the second half. Test again to see if the short is resolved and is therefore isolated to the section you've disconnected. If it has, then you know where to focus further testing and disconnecting. Through a process of elimination, you can gradually track down the source of the issue. In some cases, the culprit will be a lightning-damaged decoder. The controller will exit from the short alarm mode when the decoder is replaced. A two-wire path cable leaking to ground can be an intermittent problem depending on soil moisture level. When the soil is wet, the problem can create an error message at the controller. Earth-ground faults can be diagnosed from the controller as an excess of current in one of the two wires. The procedures for resolving ground faults are similar to that used for short circuits. You need to systematically isolate parts of the system and check for damaged cables or bad splices.